In this last part, we're going to talk about animation blending using the animation tree. So we're going to make the character go from the walk to the run animation. You can see we have analog movement, that is to say, the character changes speed based on how far I push the joystick on my gamepad. So to test that, you will need a joystick, basically, or something that gives you analog input, but you can still follow along to see how we do animation blending going from the walk to the run animation, and we'll talk a bit about the limitations of the approach we're using it and possible solutions. Let's get started. Starting back where we left off, we're going to go to the mannequin scene, and we're only going to work on the animation in this video because the analog movement itself, we already get it from the way we calculate the velocity. If you're using a joystick, the character will move faster if you push the joystick further. Anyway, click on the animation tree in Mannequin, and we have to replace our run node here by something that allows us to blend between two animations, walk and run. So select the Add Animation tool. We're going to click, and in the menu, we don't want to add an animation, but some of the blend spaces. We're going to add blend space 1D. This is an axis on which you can place several animations, and you can blend between them. So use the Select tool and select the Run node and press Delete. Then we're going to move the blend space here, and you can click the Edit icon, the pencil next to it, to enter the blend space. This is how it looks. It's an axis on which you can place animations, and you can place the cursor to have Godot interpolate between two animations. At the bottom, you can set the minimum and the maximum value for the axis and name the variable that you can change via code to control this value. So we're going to set the minimum to 0, maximum to 1, and start placing the animations in there. To do so, you have to click the Create Points icon, the pencil with a node next to it. Click that, and we're going to add our animations. So click anywhere, and you'll see you have the same menu where you can have a sub blend space in there, or you can directly add animations, which we are going to do. So add walk on one side, and in another place you want to add run. Then we have to go back to the animation player to ensure that the animations are looping. So run should be set to loop, and walk should be set to loop as well. I'll go back to the animation tree. It will reopen in the blend space. You can use the arrow, the select tool, let's say, then to select points on the curve and edit them in the inspector in case you had the wrong animation. Finally, the tool on the left allows you to sample the animation. So you have to make sure that your animation tree itself is active. Now, to preview the state of the animation, the blending, you need to make sure that this node is playing in the animation tree. At the top, you can navigate the levels of your anim tree. We can go back to root and ensure that the blend space here is playing, and click there to edit again. So based on where you place your cursor, if you place it before the walk animation and up to it, you're going to see the walk animation. If you place it after the run animation, you're going to see the character run in a cycle. And if you go in between, you're going to see the character have a mix of both animations. Now, you'll see that because of the differences of rhythm between the run and the walk cycle, there are points, areas where the animation is a bit weird. There are solutions to that. They mostly rely on creating more animations, like a jog cycle that's in between walk and run in terms of speed. And you can see that when you're getting closer to run, this looks a little more natural. It's not exceptional, but there you go. You're going to have some area where you might see some weirdness happen, like right in the middle between the two. Let's select the tool to move points, and we're going to click and drag on the points to make them pretty close. So we're going to have walk, say, at 0.3, and run at 0.4 or 0.5 to have a short transition area, so they transition pretty quickly from one to the other. And next, we're going to control that value via code. So first off, we're going to modify our blend space here, go back to the root of our animation tree, and we're going to rename it to something like moving on the ground. This will be the base node for ground movement. Then we're going to create some transitions, so go from idle to move ground and back, and from move ground to jump and back. Before, we had our node named run in the code, so we have to go rename it in the Manakini script. Open the script, and where you had the travel to run, we're going to change that to move ground. The advantage of using that enum is that we encapsulated the change so that the rest of the code will keep working. Now we need some way to control the transition between the walk and the run animation. To do so, we're going to create a property here called move direction that we're going to need to have the strength of the joystick, how far the joystick is being pushed by the player on every given frame. Let's set it to vector 3.0 by default. It's going to be vector 3, a direction vector. And we're going to have a setter to update it from our state machine. Let's call it set move direction. I'm going to expand the script editor and create the setter after the ready function here. So let's create our function set move direction. It's of course going to take direction. That's going to be a vector 3, and we're going to assign it to our move direction variable. To move direction, we assign the direction. Then we have to change the blend position parameter on the animation tree. So here's how you access it with the animation tree that we stored in our onReady variable there. You have to go through the parameters of the animation tree and then dig down to our move ground node there. And you do that way, like a dictionary. You're going to access the parameters through a path. So parameters / move ground / blend position in our case. And we're going to assign direction dot length. Our direction vector, the way we calculate it in our state machine, it's always going to have a length between 0 and 1. Now we have to assign that value from our move state in the player, because this is where we calculate the player's move direction on every frame. So let us open the player scene and open the move state script. We have to go down to the physics process function where we calculate that move direction. And so the way it works, it can be below a value of 1.0, but we already make it so that if we go past 1.0, if we're moving diagonally, the move direction vector is going to be scaled down so it has a length of 1 at most. Then we're going to assign this move direction vector to skin.move direction. So it's going to be equal to move direction. And with that, that should be it. You can play the game, press F5. I'm going to show the gamepad again, and you should be able to move the character and make it walk. And again, you'll need a joystick or something with analog input to test that. Then you have to fiddle a bit with the minimum speed your character should have, because you can see that when you make the character move from the code, the values that you use for moving are going to make the character look like it's sliding. When you animate a 3D character, you animate it based on a movement speed that is given to you by the game designers or the game developers. They're going to say the character is moving 2 meters per second or 50 meters per second or 50 units per second, something like that. And then the animator will code the walk so that, it works at that speed. Now, with analog movement, there will always be states where the movement is imprecise, unless you use something called root motion, which is a bit more complex. It requires creating more animations in general. This is an approach where the animators are going to encode the movement speed of the character in the animation in their 3D package. So it means that even when you want to turn the character or do things like these, you end up kind of having to encode it in more animations and have a more complex animation graph in general in your game. That's why we used the simpler approach of coding the character speed. Anyway, the run is kind of fine. It's just the blending in between walk and run. You can see that you can run a bit slowly and have the character's legs slide a bit on the ground. But with that, congratulations, you reached the end of this chapter. Thank you for watching until there. Now, in the next chapter, we'll add our camera and movement relative to the camera to the player to get to the final character. See you there.